MPI environment. So, MPI I showed you how to run MPI, right. You need to compile a library. So, there is a separate library which is not bundled with normal MPI, but maybe some systems are already there. So, you need to check, okay, if it is. So, you know how to check whether a library exists or not, or some function. So, you can say which the name of the executable. So, MPI CXX or MPI CC, okay. So, you just say this, then if you get some response in the command line, say version 2 point, so it will give you the version number, then you know it is exists, otherwise it not found. So, which is a way to, so it tells you which version, but if it is not there, then you will know that it is not there. So, before compilation you should always check before you try to install. One more point, if you have 2 MPI installed, there may be a problem. These are things which when you run it on your machine, you need to be careful, because if the 2 MPIs, then what will happen? So, library path, some path is there, some path is not there. So, which libraries we used. So, path has to be set. So, which I did not do it in this class, but well, Google Colab was great. We did not need to worry about all the paths, but these are issues which you need to know when you run on a computer, supercomputer or some server, even your laptop. Okay, in any case, we are not emphasizing too much on C programming language in this course. We focus mostly on Python, right. So, this was, I mean, okay, I do not think anybody is doing MPI-C, right. If you are working in a group, then you will need to, the group has the codes, like he is working with Fortran, right. No, not for the project, but for your thesis.
No, sir, I am working on ML.
Machine learning.
Yes, sir. Yes, is working on Fortran.
Okay. So, some people work in Fortran, so you need to know Fortran, and of course, it is a good language. Okay. Anyway, so that depends on the need. So, okay. So, MPI environment. Okay. So, once we have MPI, I want to run MPI. So, there will be a number of processes which I need to assign, and I need to set an environment where these processes can talk with each other, send data, receive data. And by the way, here the name of the functions will be different, but this one-to-one analog with MPI 4pi. In fact, MPI 4pi, the syntax is simpler. You see that here you have to do more work, but so MPI send, MPI receive, MPI all that is here. So, if you know that very well, then this is also very easy, except you need to know the syntax. Okay. So, MPI, so some of it is a repeat, but I am doing it for completeness. So, it is a parallel library for distributed system. Okay. Of course, we have run codes with 200,000 processors, okay, and there are people who run MPI with 1,000,000 processors. Okay. So, this is for huge number of cores, but it is true that things are changing very dramatically. Now, instead of cores we get GPUs, but still there are old codes and there are machines which have many cores. So, the default communicator. So, communicator is one which is allowing you to talk among various processors. So, the default communicator is MPI COMWorld, okay, is the name of the communicator. Okay. There are ways to get another you can create more communicators, but we will not do it right now, and you can we will have different names for those communicators, but the default one is this. So, we have set up processors and each processor has a rank. So, we will see by example. So, this is very similar to what we did with Python. So, okay, we will have different syntax. So, one first line will for invoking MPI will be MPI init. So, this is initialization. So, again at the command line for Colab, at the command line you will give the number of processors. Okay. So, if you recall, I had a dot out minus NP 4, and after okay. So, that is a number of processors how many I am using, and so this will use 4 processors, N for number, P for processors. So, this is going to go to the main program. So, main program is getting this argc and argv, and argv, this will be argv what 2, no 0 1 2, from 2 is going to get the number of processors. But for MPI init, this already there in the main. So, MPI init, though well you can so MPI init you do not put the arguments here. In earlier versions there used to be this is called argc and this was RV, but now MPI init does not require arguments, say null. So, no argument, null means no argument. Okay. So, it will take from what main has got the input, how many processors, internally it is done. Okay. So, what will MPI init do? It will create number of processors, or spawn is the word for creation, and each processor is assigned a rank. So, everybody has a roll number, okay, unique roll number. Also, please keep in mind that every processor has separate memory. The memory is not overlapping, and they cannot, one processor cannot access the other memory unless, well, you can't access, you do I only send and receive. So, this is different than threads. Threads can share memory unless it is private. Okay. So, another function we need is com size. This is a function which will give you number of processors in that communicator. So, this is a function, well, these are how functions are defined, no function, this is a type and the name of the communicator is com here, and this size is a pointer. Well, I pass as a pointer. So, when I call I will get the value, otherwise if I do not pass as a pointer it will call my value and you will not get the number of processors. It is a pointer which is being passed here. So, this will give you the number of processors. So, size is the number of processors in the COM. Okay. This is one example, the code you will find this kind of statement. So, MPI COM size is the name of the function. This is a communicator, I use a default communicator, and which variable will get the number of processors? This nprox. So, nprox is a variable, but what I am sending? I am sending the address, because I want this variable to be updated. Okay. So, when this function is finished execution, nprox will have number of processors in the communicator, which could be hundreds of thousands. Okay. But for your thing you work with maximum 16 in Bernard. Com rank, very similar strategy, but this com rank, okay, one more point. As I told before, every processor is running the same code. Do you recall this? So, we have this process, this program main, So, the same program is running on all the processors. Okay. Then say, well, same program runs, and how do I differentiate? So, this rank. So, everybody would have rank, and based on the rank your action will be, in the code has to be written in such a way that different rank will do different things. Okay. So, I have a data which is divided among ranks, like 4 processors, 4 ranks. So, we have to tell, if my rank is 0, then I will work on this process, on this data, rank is 1, then I work with this data. So, this is the job of the programmer. Okay. So, rank is very critical, everybody should know their rank, like roll number, no, that is. So, rank is the ID, and so the example is MPI rank, this communicator, this is like here COM communicator, and this is how you get the rank. So, 3 lines: MPI init, MPI COM size, NMPA rank, you just copy from the standard board. And there is one more, when everything is done, all the MPIs, I mean communication, all that has been done, and you have got the final result, then you need to finalize. So, what will MPA finalize do? It will just clean up the MPI environment. So, the communicator is gone, all the memory is cleared up. So, MPA finalize is a good thing to end. So, this you should not forget this, you should say MPA finalize then end. Okay. So, you just have to say MPA finalize, no argument. Okay. So, simple example, hello world. This is pretty similar to sequential code. So, one line we need to keep is this MPI.h. So, it is a header file which has all the functions. So, I need to include that header file, and this is same as before, right, main. Now, MPI init, this is the init. Then I define the world size integer, and I call MPI com size. So, after this function is finished, the world size will be having the number of processors in the communicator. Then we have world rank. So, MPI com rank will give you the world rank. Okay. Normally, I use also rank, I just this is a copy pasted to some other code. So, rank or nprox, I normally try to use this words nprox rank, and then print. So, what is printing? Hello world from processor with rank out of some number of processors. Okay. So, this rank world rank will be substituting this one, and world size will substitute this one, and then finalize. So, please note that this code is running on every processor. So, based on this line, all these lines are not all these lines, these two lines are giving you different results for different rank, right. So, this line when it runs, rank 0 will get its rank is 0, processor 1 will get rank 1. So, yeah, you understand. So, this is how everybody is running, but they are getting different results. Okay.
Where are we passing the number of CPU we want to run?
So, is a dot out. So, I am doing it from a dot out minus NP.
In the MPI init we are supposed to.
No, yeah, you are right. So, as I said, MPI init will take from here internally. Okay. So, main has it. So, main will pass to MPI init. So, this is to simplify stuff. It has been done. Good question, but it is taken from RV of the main. Okay. So, this is output. For Colab, we need to put these two options. Okay. We discussed it before. Oversubscribe and allow run as a root. I need to say MPI run. I can't say dot out. Okay. That was a mistake. MPI run, and the executable is here. So, MPI run is to be executed, that was a mistake, sorry. MPI run or MPI exec, you can't say a dot out is not going to work. Okay. And there are 4 ranks, so each rank is printing its a rank 1, 2, 0, 3, they are not in sequence, because whichever gets access to the console or the monitor will print first. Is it clear to everyone?